Okay, now we're doing using a different method. Remember, all of these are just tools in a toolbox of how to find derivative of functions that are complicated. So now this is what this says. This right there means the inverse function, and this means the derivative function. Remember, dy dx, another way to do that is saying y prime or f prime of x. All of those are derivative notation. So this is saying find the derivative of the inverse function. So remember the steps to finding the inverse function. And then by the way, there are different methods to do this. We are going to use the theorem method. So first thing we're going to do is we're going to find the inverse of this f of x. So you would change this to y and then swap the x's and the y's. So the x would go here, then you'd have negative 3y plus 5, and then solve for y. We're going to subtract 5 on both sides. And then divide both sides by negative 3. When we do this, don't leave the negative sign down there. So that is going to say 5 minus x over 3, or it'll say negative x plus 5 over 3. And instead of y, you now can call that the inverse function. So this is the inverse function. Well, you also have to find the derivative of this function. So if the original function is this, the derivative, well, the derivative of negative 3x to the first is just negative 3. Ooh, and for these, this is very, very key. So there's our derivative. Well, here is our inverse. And now we're going to plug all of that into this. So so the derivative of the inverse is 1 over, and see this notation right here? That means in the derivative, everywhere there's an x, so everywhere this thing right here, you're inputting, everywhere there's an x, you're inputting the inverse function. Well, on this one, so 1 over the derivative is negative 3, but notice there's no x to plug the inverse function in there. So for linear equations, notice it's just going to be the reciprocal. 1 over, and then you just rewrite that as negative 1/3. All right. So this can go away now. And I'm going to show you one where it's the cube root. So we're still going to find the inverse. So this becomes y. We're going to swap the x's with the y's. Cube root of 5 times y plus 1. The inverse of cube root is cubing. So we're going to cube both sides. Add 1 to both sides. And then divide by 5. So now we have our inverse function. Except for that should say that was a plus 1. We needed to subtract 1. Oh, I'm glad I caught that. Yeah, so we're subtracting 1 to both sides, not adding. Okay, so that right there is our inverse function. And then when there's an x in the derivative, that right there is going to get plugged into wherever there's an x. So now we have to find the derivative. So I'm going to come up here and find the derivative. So I'm going to write this to the 1/3. Instead of the cube root, I'll write the expression 5x plus 1 to the 1/3. And when we find the derivative, it's 1/3 times all, this is the chain rule, times all of that stuff. 1/3 subtract 1 is -2/3, and then that will go in the denominator. So what we have left is 1/3 times the cube root. Well, I'll just leave it to the positive 2/3. Let's go ahead and do that. I don't know if I love that idea, but yeah. So this right here is the derivative. This is the inverse. So now, when we say we're going to take the derivative of the inverse using the theorem, it is 1/. So the derivative is 1/3 times 5. But where this x is, we're now going to put that inverse function, x cubed minus 1/5, and that's to the 2/3 power. And then on the outside, remember, we've got this plus 1. Well, let's see what we have. We're going to do a lot of simplifying. So notice this 5 and this 5 cancel. All right. So where does that leave us? And then we can multiply the reciprocal, all of that stuff, but let's go ahead and hold on. Okay, I just caught an error. Notice this 2/3 is on the outside of the 5x plus 1. So here's our 5x. Then we say plus 1. Then we say to the 2/3. There we go. I knew something wasn't working out. So we already canceled the multiplying 5 divide 5. Now we've got to subtract 1 and add 1. Those cancel. And then now look at what we have. We have 3 times x cubed to the 2/3. So those cancel. That leaves 1/3x squared. And then when you multiply by the reciprocal, you end up with so the derivative of the inverse is simply 3x squared. All right, let's come down here and do another one. Oh, well, we did 2. Okay, so cool thing about this, right there, that is too complex for us to manually find the inverse. So when we go to find the inverse, not writing it like that, well, we know the inverse function, we're going to separate things out. We're just going to call it y. All right, but we can find the derivative. It is 21 x to the 6th plus 1. All right, so now when we use the formula, remember the formula is 1/f prime, and then inside there is the derivative, is the inverse function. Okay, so now we can get started. So the derivative of the inverse is 1 over, the outside is the derivative, so 21x to the 6th plus 1. Well, the inverse function, remember the inverse goes everywhere there's an x. And because this is too complex, we're just going to put y. So to simplify, 1 over 21y to the 6th plus 1. So those are a piece of cake. All right, that's it for inverse derivatives of inverses.